And then now I'm going to share my screen and we will get started. So I'm doing this from a laptop. Okay, everybody, welcome to this week's Brown Bag Lunch presentation. My name is Dane Oppenborn, and I'm really happy to see you all here today. So welcome in, and let's do some housekeeping first. We're going to open with a land acknowledgement. We acknowledge that Cal Poly Humboldt is located on the unceded lands of the Wiyot people. Arcata is known as Gudini, meaning over in the woods or among the redwoods. We honor them and all neighboring tribes by our ongoing commitment to developing trusting, reciprocal, and long-lasting partnerships. Here at OLLI, we believe that lifelong learning should never end. OLLI creates opportunities for academic engagement, civic involvement, personal growth, and fun. By offering a myriad of classes and experiences for a vibrant community of learners aged 50 and better, OLLI delivers learning for a lifetime. Excuse me. So a little bit about the OLLI program here. It is a membership program. It runs from July 1st through June 30th, and membership must be renewed each year for students to remain active. Primary membership for people 50 and better is $35 annually. You don't have to be older than 50 to join the OLLI program, but a lot of our program is designed for community members 50 and better. OLLI classes are designed for lifelong learners 50 and better, like I just said. Classes are open to all learners over the age of 18. Non-members pay an additional charge and are enrolled as space allows. But there's actually some really great benefits to being an OLLI member, and I'm going to go over some of the lists with you. So you get lower class fees and a priority registration when you're an OLLI member. You're given a Cal Poly Humboldt email account, and this email account gives you access to the full professional version of Zoom, as well as other campus softwares that are really powerful and useful. OLLI members get discounts on the Jack Pass. They get eligibility for course scholarships. They get student discounts at local businesses. They can participate in OLLI special interest groups. You get library access with a student ID card included with your membership, which is really cool. And you also get gym and recreation center access on campus with a small fee. Another program that we have every Friday is we have our Let's Connect OLLI online conversations with Tracy Barnes Priestley. These are free weekly chat sessions. They happen on Zoom every Friday from 10 to 11. They kind of started because everyone was isolated during the pandemic. These kind of started as a way to bring people together, just to keep people talking, keep people interacting. And it was so popular that we decided just to keep it going. So yeah, if you want more information on that, please reach out to us. I forgot which next week, I don't have next week's topic on hand, but yeah, it's a great program, and everyone who is in the weekly sessions are having a great time. Like I mentioned at the beginning of this, we record all of our brown bag presentations and we archive them. So if you ever wanted to check out an older recording that we've done in the past, you can do that on our website and on our OLLI YouTube channel. youtube.com/@OLLIHumboldt. And if you have any questions about our classes, our programs, anything you're curious about, please give us a call at 707-826-5880 or email at us at olli@humboldt.edu. We check those inboxes pretty regularly. And without further ado, I will pass it over to Jane, who will introduce our presenter today. Jane?
And our presenter today, welcome, by the way. We're happy to see you here as we always are. And Lori Dengler is a friend of OLLI, an emeritus professor of geology at Humboldt State University. She's pretty well known in the community because we see a lot of her. She has expertise in earthquakes, tsunamis, and hazard mitigation. Since retiring from teaching, She continues to provide scientific advice to the Redwood Coast Tsunami Work Group, engage in earthquake and tsunami outreach projects with California Office of Emergency Services, and writes the Not My Fault column that appears in the Eureka Time Standard most Sundays. She's also done a multiplicity of other things that have been wonderful, and she shared a lot of those with us on our Brown Bag Lunch program. So it's all yours, Lori. Thank you.
Thank you very much. I hope everybody can hear me okay. And before I introduce my topic, I know that some of you are aware that I had a bit of a mishap a little over 2 weeks ago, where I was the pedestrian in an auto-pedestrian interaction. I am recovering, but sometimes my brain fogs out a little bit on me. So hopefully you'll ignore any gross errors. So I'm going to be talking about last December's magnitude 7 earthquake, which I expect many of you experienced in one way or another. But before we really jump into the earthquake, I do want to emphasize what are always the most important parts of my talk, which is when the next earthquake happens and you feel the ground begin to shake, be sure to do the right thing, which is pretty much stay in one place. If you are able-bodied, that means dropping down to the ground, covering the back of your head and neck with your arm, and if there's a sturdy table or desk nearby, going underneath it. Now, I have artificial knees, so I don't do this, but I do just stay in my chair or take a seat close by, bend over, and again, cover the back of my head and neck with my arm. Next step is knowing whether or not you are in a tsunami zone. I'll talk a little bit more about this week's exercise in just a moment. If you are in a tsunami zone, the earthquake shaking is your alert to head inland or to higher ground. Helps to know what the tsunami zone is ahead of time, and I'll talk a bit more about that in a minute. And then it's just as important once you are out of the tsunami zone to stay there, because the tsunami hazard may last many, many, many hours. If you are not in the tsunami zone, stay where you are. Over evacuation puts you and other people at risk. Coming this Wednesday is North Coast 3-county tsunami drill. This is the first time we've done that. This is Tsunami Preparedness Week in California. And usually in the middle of that week, we do a tsunami communications drill where we pretend a big earthquake has happened far away and the tsunami has many hours to reach us, and we test our ability to communicate that. Well, we all had a real run of tsunami communications last December, so there's no need to repeat that. Instead, we're really encouraging everyone at 11 a.m. on Wednesday, no matter where you are, to pretend an earthquake has happened. If you're signed up for county emergency alerts, you should get an alert on your phone saying the drill has begun. If you are in the tsunami zone, that is your signal to grab your grab and go kit, grab your kids, and dog on a leash. And man, if you have a well-trained cat and can get that cat into a cat box, fine. Otherwise, the cat's going to need to fend for herself. Head to a safe area outside of the tsunami zone. Again, if you're like me and you're not in a tsunami zone, just stay where you are. So that's this Wednesday. Other than that notification on your phone, there will be no other kind of guidance. You're going to have to do this on your own because that's exactly what will happen if we have a really great earthquake. In the introduction, you learned a little bit about being on the land of the Weot. Well, no matter where you are in California, you are living where Native peoples lived before you and still live today. And I show up this slide not just to acknowledge the people who are still here and were here before us, but because they provide a really important source of information about past earthquakes and about past things that happened prior to the advent of European Americans. So fortunately, we do know something about great tsunamis of the past through the Weot, Yurok, Tolowa oral history. And it's important to, I'm very glad that we have it. So I'm going to start out, we're focused on the Mendocino Fault, which caused the December 5th earthquake. And I want to step back a moment to kind of explain how the Mendocino Fault came into existence. So over here on the left, I'm showing what I hope is familiar to many of you. It's a picture of the Mid-Atlantic Ridge today. Today we have Africa and South America, Europe and North America are spreading apart. The Atlantic Ocean is getting bigger every year. And this little green and red zigzaggy pattern shows the Mid-Atlantic Ridge today. The areas in green are places that are spreading apart, and the places in red are what we call transform faults, which kind of adjust. I mean, when you're trying to spread something on a sphere, you can't do it linearly. So these transform faults adjust to the spreading centers on either side. Now over here on the right, I have an animation that was put together by friend and colleague Tanya Atwater many years ago that tries to recreate the Pacific over the last 80 million years. And 80 million years ago, there was a ridge very much like what we see today in the Atlantic. And once again, there are spreading centers and there are steps. And we're going to kind of pay attention to this one right here and look at how that ridge system is moving closer and closer and closer to the coast. Boom, about 40 million years ago it hits. And right there is today's Mendocino Fault. So let me go to our next slide and look at this in a little more detail. So now this is about 40 million years ago. Obviously, nobody recorded what was really happening. Tanya Atwater did an incredible job based on today's geology working backwards. So what really happened might be a little different, but this is a good model. So here again, we have, and right there, I've stopped it. This is the point where the first part of the ridge hits California. So right around 30 million years ago, that ridge hits roughly where Los Angeles is today. But we continue to have spreading. And roughly 10 million years ago, let me go a little further, 10, 12 million years ago, we're hitting right about where San Francisco is. And notice that where there used to be the subduction zone, now we have a straight line. That's the San Andreas Fault. The San Andreas Fault was born roughly 30 million years ago when we have that first contact. And as more and more of the plate subducts beneath North America, this triple junction right here, which we'll get back to, I'll give it a name in a moment, heads to the north, and the San Andreas Fault gets longer and longer. So now we're kind of Clear Lake, and finally, roughly 1 million years ago, this triple junction, which we now call the Mendocino Triple Junction, because it's right next to Cape Mendocino, this is where it is to get today. So we have this little plate remnant of what once covered the entire Eastern Pacific. We now call this the Juan de Fuca and Gorda Plate. We still have a little bit of spreading centers out here and out here. And right there, that is the Mendocino Fault. So if we look at where we are today, we actually see in the bathymetry, this slide on the left is showing you the depth of the seafloor, which is by no means uniform off of the Northern California coast. It's very, very deep off of the Mendocino coast. It's very shallow off of Humboldt del Norte County. That's why the Portuguese, the folks from the Azores who first settled this area in large numbers, named it the Gorda Basin. It was the fat basin. It was a great place to fish. And we see this very distinct bathymetric expression along the Mendocino Fault. We see the shallow area along the Gorda Ridge. This is a divergent boundary where there's spreading, transform boundary on the Mendocino Fault, compressional boundary along the Cascadia subduction zone. And here's just all of that made easy. So again, Mendocino Triple Junction, the place where the three big faults, the San Andreas Fault, the Mendocino Fault, the Cascadia subduction zone meet, and where the three plates, the Pacific, North American, and Gorda, are basically touching. So let's really jump into what happened on December 5th in a little more detail. And first, a little bit of terminology. The Mendocino Fault, where there's active slip going on today, but further to the west, if you look on a Google Earth map, you'll see this enormous scar that extends, 3,000 miles offshore. No earthquakes there, no slip today. We call that the Mendocino Fracture Zone. The Gorda Ridge, actively spreading. The Blanco Fault, which is similar to the Mendocino Fault, it's another one of these transform faults, but notice it's at an angle to the Mendocino Fault. That accounts for the crushing of this little Gorda Plate and lots of earthquakes within the Gorda Plate. And then in white, I'm showing the aftershocks, well, the location of the 7.0 and the first month and a half of aftershocks. And the kind of in orange, the orangey zone beneath, that's again indicating this triple junction area. So here I'm focusing just on the Mendocino Fault and earthquakes since 1915 that were likely on it. Now, obviously, we didn't have good seismographs in 1915, and you can see that there's a lot of scatter. These older earthquakes probably really do line up more tightly. So here's just kind of an overview of what I'm going to be talking about. I'll start out talking about the earthquake, shake alert, and the wireless emergency alert that many of you received, ground motions, damage, geologic effects. Then we'll jump into the tsunami, why there was a tsunami warning, how it was disseminated, what went right, and areas where we could really improve. Aftershocks, we had an aftershock early this morning. We're still in the aftershock phase of that earthquake. And then finally, I'll try to put this into context, how it related to other recent earthquake, how common this was, and what do we really need to think about future earthquake and tsunami hazards. So many of you, I expect, if you were on the North Coast, received an alert on your cell phone at around 10:44 a.m. And this was a situation where I'm located. I got a notice of a 6.0 earthquake centered near Scotia. And the alert was drop, cover, hold on. Again, I don't drop, I sit in my chair, but I became very, very conscious that maybe I was about to feel an earthquake. And about the time that message ended, I began to feel very weak shaking. And then about 6-7 seconds later, the shaking got a bit stronger. It was never strong at my house. There was no creaking, nothing fell. The whole duration lasted about 45 seconds where I'm sitting, but I'm pretty good at counting out duration. Other places were very different. Over here on the right is an illustration of how the shake alert system works. First of all, it's not earthquake prediction. When I got that notice on my phone, earthquake, earthquake, drop, cover, and hold on, they weren't just going, oh, a bird or a goat or my dog started barking. It was based on the fact that the earthquake rupture had already begun and seismic stations closest to the epicenter had already detected it. And as soon as 3 seismic stations are able to triangulate a location, that's what they do. So in this particular case, because the real earthquake was located roughly 40 miles offshore, we don't have ocean bottom instruments. It had to wait for the seismic waves to hit the seismic stations in the Cape Mendocino area. It took about 15 seconds for that first alert to be issued. For an earthquake on land in an area where there are many seismic stations, that usually takes about 5 seconds. So then a whole series of algorithms jump in and estimate where the earthquake is, what its magnitude is, and how strong the shaking is going to be as you get further away. And if the earthquake for the USG is typically magnitude 5, if you have my shake, it's more like 4.5. And the shaking strength is equivalent to what we call intensity 3 or 4, which means if you're indoors, you'll notice it. If you're outdoors walking, you probably won't. Then the information gets sent via wireless providers, private companies, to all of the folks in areas that are likely to feel it. So what happened actually on December 5th? Well, these polygons show you how their estimate of the intensity changed and how the location changed. So first it was a location here, a 5.6, then a 6.0. For a while, the location jumped further offshore. It finally settled here. And this is all happening in seconds. So the first alert issued 15 seconds. Over the next little over a minute, we get these ever enlarging polygons. The last alert was issued 89 seconds after the earthquake, certainly after all of the people in this area would have felt it. and it was estimated as a 6.9. At that point, shake alert stops because there's no point in trying to do an early warning, and the normal USGS locations start. But this is what the message looked like on my phone. Earthquake detective, drop covered, hold on, protect yourself. I love shake alert. I think it's great to have a little bit of heads up, even if it's only a second or two, to expect shaking. So now let's talk about the impacts. And I'm comparing this actually to the earthquake that many of you may remember more vividly, the December 2022 magnitude 6.4. So here's our 7.4, felt by many from Salinas up into Southern Oregon, inland to the Lake Tahoe area, and then felt by a few as far away as Vancouver, British Columbia, and San Diego. When we look at the shaking pattern of the 2022 earthquake, was not felt nearly as widely. It was felt to basically Salinas, Monterey area. A few felt it in Seattle and Olympia, and not as many little squares there. But just how widely an earthquake was felt doesn't tell you, obviously, the whole story. Ground motions give a better picture of what actually happens. And we have instruments, all these little triangles are instruments that actually record the acceleration of the ground. And then these other sort of circle spots are places where ground motion has been interpolated from people's reports of shaking. So the December 5th earthquake was about 40 miles offshore. Obviously, if you'd been in this area, it would have shaken you really strongly. But closest places on the coast averaged just under half a G. Now, a G is the acceleration due to gravity. If the acceleration is greater than a G, that kind of makes you weightless. So this was, our strongest acceleration was right there, 0.4 G, but most of the populated areas did not experience ground motions anywhere near what happened back in 2022, where in Rio Del, there were 3 accelerometers that recorded over 1 G of acceleration and one 1.44. So that earthquake was much closer to the coast. It ruptured towards the coast and resulted in an estimated nearly $100 million worth of damage. In contrast, damage in the December 2024 earthquake, somewhere estimated in the $10 million range. That's mainly to roads and bridges where relatively minor impacts were observed for the most part. Yes, there was damage. Lots of items off shelves in markets, a few chimneys damaged, 2 structures reported with some foundation damage, broken windows, gas leak. But basically, for a magnitude 7 earthquake, we got off pretty darn well. There were also geologic impacts, beautiful liquefaction on the Eel River, spread failures, landslides, Shively Road, Blue Slide Road, and then the good old Fleener Creek Slide, which had a massive failure about nearly a year after the 2022 earthquake. Well, it moved again. So whenever there's an earthquake here and you're driving, especially at night, realize that the road may have been damaged, especially the approaches to bridges. So you want to always be very careful. All right, that's the earthquake part of the story. No real surprises. Again, we were lucky. Magnitude 7 earthquake does relatively modest damage, certainly compared to a much smaller earthquake in 2022. Many more people were impacted by the tsunami warning. So here's just a little timeline of what happens. Earthquake 1044. We get the alert, the shake alert, 15 seconds later. And then the first tsunami bulletin is issued by the National Tsunami Warning Center about 5 minutes after the earthquake. Tsunami warnings, unlike shake alert, are not automated. People have to examine the data, and that takes a little bit of time. And so the first bulletin estimated a magnitude of 7.3. Now note the shake alert final estimate was 6.9. The USGS, after about 10-15 minutes, comes up with a 7.0. The Tsunami Center has 7.3, 5 minutes after the earthquake. That's going to be important, because if they had had a 6.9, I wouldn't be talking about the tsunami warning, because there wouldn't have been one. So in that first bulletin, it says a tsunami warning is in effect. It gives the area, which I'll get into more in a minute. And it talks about the time of the first wave arrivals. Fort Bragg at 11:10, Crescent City at 11:20. Humboldt Bay would be about midway in between, so roughly 11:15, and San Francisco 12:10. Note, there's not a lot of time. There's only about 20 minutes between the time of this bulletin and the first wave arrival at Fort Bragg. So when we're dealing with what we call a near source tsunami, there's no time to really check all the instruments, check all the models, check all the data. You really have to immediately make a decision, because there's just no time to mess about with, well, what is it? When you have an earthquake like 2011 in Japan, we had 9.5 hours for the West Coast between it happening and the first tsunami arrival. That gives you a lot of time to assess how significant this is. And then there was a second bulletin about 35 minutes later, and finally about 70 minutes after the earthquake, cancellation. I want to take a brief moment to review the kinds of products that the Tsunami Warning Center issues. So there are 4 products, ranging from an information statement. They issue one of those almost every day. And usually it's because a magnitude 4 earthquake has occurred in Alaska, and people might have felt it, but it's not going to produce a tsunami. So typically any earthquake under magnitude 6.5 that people are likely to feel, you're going to get an information statement that no tsunami is likely. Sometimes it's issued when a major earthquake has happened and they haven't figured out where this earthquake falls yet. So the threat has not yet been determined. Then we move into a watch, which means it's at least 3 hours away from you, the first wave. It may become a warning or an advisory, or it may be canceled. Watches do not get issued very frequently. And then we get to the 2 actionable events. Advisory is kind of the most common alert that we've gotten on the North Coast. It means strong currents in harbors and bays, danger on beaches, but no threat of flooding above your high tide line. So an advisory was issued after the Hunga Tonga eruption in 2022. And there were strong currents and there were people caught, not in Humboldt County, but in San Francisco and in Southern California. The highest level of alert is a warning. And that means not only strong currents, but we could end up with inundation above the high tide level. Now, there's a whole range of potential warning events. It might be 3 or 4 feet high, or it could be 60 or 80 feet high. In the United States, we don't differentiate. They're all put in that same warning bucket. In Japan, they actually do differentiate, but they've got a lot more experience and instrumentation. So the other thing to be aware of is that the US has 2 tsunami warning centers. They both issue messages, and those messages may seem contradictory. So all of Alaska, Canada, and the contiguous 48 states are under the National Tsunami Warning Center. We get our information from Palmer. Actually, I just realized this is an older slide. Puerto Rico should now be orange. Puerto Rico, Hawaii, Samoa, Guam all get their marching orders from the Pacific Tsunami Warning Center, as well as roughly 26 countries who get advice from the Pacific Tsunami Warning Center. So I mentioned those 3 bulletins that NTWC issued. Well, PTWC issued 2 bulletins that same day. The first saying hazardous tsunami waves possible for coasts within 300 kilometers. Turns out right there, that doesn't agree with what the National Tsunami Warning Center does. This is all you need to know about every possible earthquake located anywhere in the world and whether or not a tsunami warning or advisory or watch will be issued. I don't expect you to be able to read it. All I expect you to look for is this column, which is the West Coast, and these are magnitudes. Notice that all the magnitudes less than about 6 are going to be green, which you're only going to get a statement for. We're over here at 7.3. We go over here and we read the fine print. And what the fine print actually tells us is that all coastal areas within 250 kilometers of the source will automatically be put into a warning, not an advisory. Plunk, warning, automatic. So what does that look like for the US West Coast? Here's where that 7.3 initial, again, remember it ended up 7.0, where it was located. And I've just drawn a 250 kilometer circle. So all of the coastlines from just north of Brookings, Oregon, to just into Sonoma County are in that warning area. However, the actual warning was issued from here down by Santa Cruz all the way up to just south of Florence, Oregon. Why? Well, it has to do with the kind of antiquated National Weather Service system of breakpoints. You always have to issue a uniform alert between breakpoints. Notice there's a breakpoint at the California-Oregon border, and there's one in Mendocino County. But our 250 kilometers extends just beyond them, which means that we have to go to the next breakpoint up here south of Florence, down here in Davenport, in Santa Cruz County and put all of this area into a warning. Not only does all of it go into a warning, but the entire San Francisco Bay, all of the land around the bay is also put into a warning. So this is what over here on the right is what that warning map looked like on December 5th. And notice there's a whole lot of red in that, which is perhaps one of the reasons why we had major over evacuation going on. So here's the map in the middle. If we look at the actual mapped tsunami zone by the state of California, the yellow is the actual hazard. Green is safe. Here I've zoomed in over here on the right at just the San Francisco Peninsula. And you'll notice almost all of San Francisco, even in the worst case tsunami, is fine. It's only these low-lying areas shown here in the yellow that are at risk. But unfortunately, the map doesn't delineate that. So that's kind of problem one with understanding what happened on December 5th and why many people were concerned who probably shouldn't have been. What went right? The WIA alerts for the earthquake and tsunami were actually sent very quickly. In orange here, I'm showing those earthquake early warning alerts, and the reason they keep getting bigger and bigger is because of the changing magnitude estimate. And the red shows all of the areas that got a second WIA alert 5 minutes after the earthquake that a tsunami warning had been issued. Now, what did that warning look like? This is just a screen capture of my phone. The National Weather Service has issued a tsunami warning. A series of powerful waves and strong currents may impact coasts near you. You are in danger. Get away from coastal waters, move to high ground or inland now. Keep away from the coast until local officials say it is safe to return. Well, boy, you get this, and maybe you're in eastern Contra Costa County. You are in danger, and you kind of go, huh? What does that mean? This is actually the first time a WIA tsunami warning is sent to West Coast residents. So needless to say, there's going to be a little wordsmithing going on before we do it again. There was a small tsunami. It was about 3.5 inches high in Mendocino County. And some people in Humboldt Bay observed it looked like the bay was draining and then filling and draining and filling. This is the tide gauge from the North Spit. And you can see these series of characteristic oscillations. These are called seiches. Any body of water has a characteristic period. In the case of Humboldt Bay, it's just under an hour. And it turns out a lot of things can generate seiching. Big storms, sudden pressure drops, even the sudden draining, the ebb flow of Humboldt Bay. But it also appears that earthquakes can trigger this. We saw after the Denali earthquake, the big 7.9 in Alaska in the early 2000s, we see a beautiful series of seiches. So not hazardous, but interesting. There were actually a number of examples of things happening right on December 5th. And I really want to applaud the schools, both in Del Norte County and Humboldt County. These are students at Redwood Coast Montessori on the Samoa Peninsula. They practice tsunami drills every month. They felt the earthquake, they protected themselves during shaking, and then all the kids immediately grab their grab and go kits, go up to the high dune, which is considered safe. And for 70 minutes, the 125 students and staff stayed there. They did it exactly right. Crescent City managed to completely evacuate their downtown area in the tsunami zone in 15 minutes. That meant some people did vertical evacuation, other people walked out of the area. What went right? Well, the three counties, Del Norte, Humboldt, and Mendocino, all issued emergency notifications when the warning was issued, but they actually qualified the alert saying, leave now if in a tsunami zone. That helps a whole lot because at least we're not telling everybody you are in danger. One of the biggest problems in Humboldt County and actually in much of the Bay Area were too many people jumping in their car to evacuate. The result was monster traffic jams. And sometimes that meant you were stuck in a place where you're actually in a tsunami zone. This photo is actually not from December 5th, but it illustrates where you don't want to be stuck in traffic, which is on 101 in the real low area between Arcata and Eureka. Don't evacuate by car. This was a small event and it caused over an hour's worth of traffic jamming in Eureka. That affects, and there was actually one injury in the Bay Area due to a panicky evacuation. So if you're not in a tsunami zone, don't evacuate, and don't evacuate by car, ever. What went wrong? Well, we're still kind of compiling information on what went wrong. And if you got this message saying you are in danger, you might want to immediately find out, well, what is the tsunami zone? And a lot of people headed to this website, the California Geological Survey's tsunami page. And they would have found that they couldn't get on. So way too many people were going to the page. Hopefully that's been fixed, but the time to find out if you're in a tsunami zone is not during the tsunami, it's ahead of time. This website crashed. Our website, Redwood Coast Tsunami Work Group, we have a whole page on tsunami hazard maps. The links to the state map wouldn't have worked, but we have a whole bunch of maps of communities in Mendocino, Humboldt, and Del Norte, and you certainly could have seen those, but very few people know about them. What went wrong? Over evacuation, over evacuation, over evacuation. Evacuation is hazardous. People can get injured in a number of ways. You can drive too fast. We know you shouldn't be driving, but the potential, if you've got a lot of people evacuating on roads by foot and you've got people panicky evacuating in cars, that's not a good mix. I throw out these two maps showing the current tsunami hazard zones for the Eureka area and for the Arcata area. Again, you can get maps for all of North Coast communities by going to the Redwood Coast Tsunami Workgroup page. The areas in green are safe, even from a magnitude 9 earthquake on the Cascadia subduction zone. This boundary between yellow and green is not showing where the water will go. The California Geological Survey has spent a lot of time studying past tsunami events, modeling potential tsunami events, putting in high tide, and then adding an extra meter in elevation of safety. Now, a meter is a lot when it comes to a tsunami. And so a real worst case tsunami is unlikely to ever get very near this green line. So everyone, basically 101 and north, or 101 and south, you're safe, okay? No need to, it's really only the Old Town area where there's a potential threat. You do not need to evacuate if you're in the green area. Again, in Arcata, the populated areas of Arcata are safe. I heard reports that Peninsula School evacuated, even though they're way far away from the edge of the tsunami zone. Now, I understand that desire to be cautious, but keep in mind that evacuation poses threats, and you are often safest in your own home if there's not been significant earthquake damage. So learning to not evacuate is just as important as learning when you need to evacuate. Let me talk a bit about after December 5th, because we are still having aftershocks. Whenever you have an earthquake of this size, magnitude 7, there was about a 25 to 30 mile long fault that slipped. The two sides moved, but they didn't move nice and smoothly. Some patches moved more than others, and obviously at the ends, it didn't move at all. So aftershocks are nature's way of readjusting to the new stress regime. This is a very typical aftershock pattern. Lots of aftershocks the first day, rapidly diminishing, and then getting into kind of a steady state system. And this only goes into early February. But as I said, we're still in the aftershock period. More aftershocks and larger aftershocks in those first 24 hours. So we had 1, 2, 3, 4, 5. We had 6 aftershocks in the magnitude 4 range. Another 3 the next day. And then you see we're not having quite so many. But note that the largest aftershock occurred nearly 2 weeks later, 5.3. And as early as early February, we were still having magnitude 4s. So we're not done with aftershocks. The USGS publishes aftershock likelihoods based on statistics of other earthquakes. So I'm showing you 2 of their probability maps. The one over here on the left were what they published on the day of the earthquake, December 5th. And this is the odds of having an earthquake in the magnitude 3 range in the next week Well, it's essentially 100%. Duh. The odds of having a magnitude 4 aftershock, nearly 90% in that first week. Magnitude 5, about a third chance, but note there's also probabilities for a large aftershock or an aftershock of equal size, which is no longer an aftershock. It makes it a doubleton or an even larger earthquake. So on that first day, there was still less than a 1% chance that we would produce another magnitude 7. The graph or the table on the right are what I pulled off the website yesterday. And this now is the 1 month odds. So after a month or two, instead of doing weekly odds, they shift to monthly odds. And note, we're still at essentially 100% likelihood of more magnitude 3 aftershocks in the next month. We've dropped down to less than 50%. Magnitude 4 aftershocks, 38%. But, it would not surprise me. Eventually, we go back to what we would call normal background levels, which means we always have a chance of magnitude 3, 4, 5, 6s, and 7s. They'll all be little less than what we're seeing here. But on the North Coast, the likelihood of a magnitude 3 happening in any week is always going to be very high. Now, there are a lot of interesting side stories about the December 5th earthquake. And I was really impressed by the scientific response. After 1992 and our 3 big earthquakes in the Triple Junction area, we got quite a few scientists coming up to study it, but not nearly as many as came up to work on various aspects of our magnitude 7. Over 125 portable instruments were deployed. Some of these relatively simple instruments, others more complex. We even had a whole bunch of offshore ocean bottom instruments. Had those been in place on December 5th, it would have taken 5 seconds to get a shake alert out, not 15 seconds, because they would have detected the earthquake more quickly. And then really, one of the most terrific stories is the Arcata DOS optic fiber experiment, distributed acoustic sensing. The USGS has been partnering with Poly Humboldt and a number of other folks in trying to understand if optic fibers, in other words, those underlying communication cables that run our internet, telephone, and so forth, whether they can also be used as seismometers. And there have been 3 experiments that have been run on this little line. You can actually see it. It's on Old Arcata Road between Eureka and Arcata, which fortunately, due to the optic fiber companies and researchers, we've been able to use this as a testing bed before the optic cables are actually in use for communications. And this diagram, so the cables, the cable runs from Arcata to Eureka, and you can see Arcata over here, the Eureka PG&E substation. So basically, every one of these lines is kind of like a separate seismogram. And you can see the magnitude 7 beautifully recorded. And it really lends strength to the ability to use these optic fibers as seismographs in the future, especially when the cables are oceanic, and gives the potential to have instrumental data in the offshore area at a relatively minor cost compared to putting out a whole bunch of ocean bottom seismographs. The last thing I want to talk about is putting this earthquake in context. There was no surprise about that earthquake. Again, I've sort of repeated this graph I showed earlier of magnitude 5.5 and larger earthquakes since 1915. We've had 70 since 1915, including these three, 1923, 1994, and 2024, that are all in the magnitude 7 range. So no surprise about where this earthquake was, and we will certainly have more of similar size in the future. All of those three that I showed certainly could trigger a tsunami warning, as happened on December 5th. But those aren't the only earthquakes on the North Coast that are likely to trigger a tsunami warning using the current National Tsunami Warning Center criteria. This shows historic earthquakes going back to the 1920s that are close enough to that magnitude 7.1 threshold that the initial magnitude that the Tsunami Warning Center gets would throw our area and potentially a very large part of from the Bay Area into Oregon into a tsunami warning. So any of these earthquakes, now note these aren't on the Mendocino Fault, but turns out the Gorda Plate is quite capable of producing magnitude 7 earthquakes. The only one of these earthquakes that actually produced a tsunami that we would consider warning credible was in 1992, the 7.2, where a tsunami as much as 3 feet high was observed in College Cove. So what happened last December could easily repeat. Here's another way of looking at the frequency of large earthquakes and tsunami alerts in Northern California. So up here on the top, I've just plotted earthquakes of magnitude 6 and larger. So that's the 6 and larger, obviously lots of magnitude 5s, since 1900. I've also included the 1906 earthquake here because it ruptured all the way up to Cape Mendocino. And again, you can see we get lots of earthquakes and they're clumpy. We might go more than a decade with not much happening. And then we get a decade where, boy, earthquakes are really on the mind. Down on the bottom, I'm showing a very different kind of graph. Tsunami alerts, a warning, an advisory, or a watch that would likely have been issued going back to 1900 for our area using modern day protocols. Now, our first tsunami warning center was not operational until the late 1940s. So, and we've changed the procedure since then. But you can see that tsunami warnings are not all that uncommon. Most of them have been triggered by large earthquakes far away. But again, those 7 I just showed you would have all triggered a tsunami warning as well. So it's really important to have an understanding of how frequent these are and the appropriate way to respond. The second thing I want to point out is our earthquakes don't occur in a vacuum. They're all related to one another. And so back in December 2021, we had two earthquakes. We had a 6.0 on the Mendocino Fault, followed by a second 6.0 on a fault in the Gorda Plate. These two earthquakes were 11 seconds apart. You wouldn't have even felt them as separate. But that set up the stresses that certainly led to the 6.4 in 2022. And if you look at the way that fault moved, it certainly relieved, kind of made it easier for our 7.0 to happen. This is Bob McPherson's little model. He's going to be writing up a paper on it. But it really illustrates how none of our earthquakes happen in a vacuum. And these aren't the only faults. We've got the monster rupture in 1980. We have lots of other faults in the Gorda Plate. We certainly have other areas of the Mendocino Fault that haven't ruptured recently. And of course, we always have the Cascadia subduction zone. So let's look to the future. More earthquakes and more tsunamis. However, they are likely to occur in a time where our earthquake and tsunami monitoring programs are at risk. It takes a lot of equipment. It takes a lot of brain power. It takes a lot of person power to maintain the equipment, and of course, to develop new equipment. And I'm just showing two examples here. This is the DART system, the deep ocean sensors that sit on the seafloor and do an incredible job of assessing the tsunami potential, particularly when a big earthquake occurs far away. In 2011, the DART sensors here off of Japan were sufficient to do forward modeling of the likely tsunami size in California. The estimate was 2.5 meters in Crescent City. The actual recorded peak was 2.49. It's wonderful to actually have a sense of how big a monster is coming at you. And this is the kind of tool we need. Otherwise, we don't know. Is it going to be little, or is it going to require evacuating the maximum zone? The shake alert system, again, it requires a dense network of seismographs that requires a lot of seismic technicians. We may be losing our North Coast seismic technician because of the closure of federal office buildings, which means it'll take longer to repair and keep our stations online. Plus, these systems are just the beginning. I mean, we're in an age where machine learning may really improve our ability to tell the difference between a tsunamigenic and non-tsunamigenic earthquake. All of that requires investment in people and research. So to finish up, right now and in the future, personal and community preparedness is your very best chance to ride out the next earthquake or tsunami safely. And I often like to close with my story of the Simeulue Islanders. In 2004, the worst tsunami disaster of historic times in terms of lives lost struck the Indian Ocean, with over 220,000 deaths and damage significant damage to, I think it's 14 countries in the Indian Ocean. I was fortunate to be part of a post-tsunami field survey team 4 months after the tsunami, where we visited the hardest hit areas of Indonesia. And the last place we visited was Simeulue Island. This is my photo on the right. This is a photo taken by a team of Russian researchers 2 weeks after the tsunami. Simeulue Island, and especially Langi Village, where I was the closest population center to the epicenter of the 2004 earthquake. The earthquake was strong. In fact, it shook the ground for over 5 minutes in this location. And the first tsunami surges arrived 8 minutes after the earthquake began. When I visited Simeulue, I expected to see the same thing we saw in Aceh province. Homes destroyed and 90% of the population annihilated. It's really depressing. But on Simeulue Island and in Langi Village, not a single man, woman, or child had died. When I visited and I took this picture 4 months later, they had rebuilt their homes on the same platforms. And everywhere we tried to work, we were followed by basically the whole village. It was wonderful. The children, the elders, everyone was alive. And when I asked, how did you manage to survive? They told me the story of smong, S-M-O-N-G, which in the Simeulue language means strong earthquake that lasts a long time, changes the ground level, and is followed by tsunami surges that may last for days. I mean, all of that is encompassed in the word smong. And it comes from their oral history, where they've experienced earthquakes and tsunamis in the past. This is a village that's completely offline, no electricity, no computers, and yet the elders pass on the information to each generation that when you feel the earth move for a long time, you immediately grab the children and you put Granny in the garden cart and you go up the hill and you stay there. And you stay there typically for 2 weeks because they have no way of really knowing when the danger period is over. Great tsunamis don't happen that often on Simeulue Island. The last one that killed anyone was about a century earlier in the early 1900s. 5 generations later, and many, many earthquakes that have not produced tsunamis, they are still, every single time they feel that long duration earthquake, up the hill they go. And when I asked them, well, aren't you concerned about a false evacuation, an unnecessary evacuation? They looked at me as if I were crazy and said, every earthquake is a chance to practice our evacuation skills. So be like Indonesia's Simeulue Islanders. Feel an earthquake, go to high ground, survive. The things that are in your control, you can reduce hazards before the next earthquake. You can know your tsunami zone. You can know that earthquakes that shake a long time. And when I say a long time, if you're not sure if it's a long time, we say, when in doubt, drill it out. But you'll know that this is a long time. That is your warning. If you're in the zone, evacuate by foot. Don't get in your car. About half of the victims of the 2011 Japan tsunami died in their cars. Out of the zone, stay where you are, shelter in place. So my talks are always built on the work of dozens of colleagues, many organizations. I thank all of them. And please go to the Redwood Coast Tsunami Work Group for all kinds of information. We've just put up a new page on the December 5th earthquake. We've got a page on 1964. We've got all kinds of stuff there. And for the latest information, follow us on Facebook. And that is the end of my presentation. Questions?
I have a question. You had, on the Gorda plate, you had 3 sevens that were sort of in the middle of the Gorda plate, and I wondered about that. I would expect them to be in the subduction zone, but is that because the Gorda plate is bending before it heads underground?
Let me just, no, and you've actually hit on, let me stop the share. Okay. A very common misconception.
Oh, good.
With the exception of 1992, which may or may not have been on the subduction zone, and now maybe 1954, which we're studying right now, we have had no significant earthquakes on the Cascadia subduction zone in instrumental historic times. Zero. It's stone cold quiet. Oh, there have been a few tiny, after the 1980 earthquake, there were a few magnitude 3 aftershocks that looked like they were close to the zone. The Cascadia subduction zone is considered a locked subduction zone that is stone cold quiet and really hasn't done anything in the last 325 years. Our last subduction earthquake was January 26, 1700. We think it was a magnitude 9. Since then, the subduction zone has been quiet. That's not a surprise, because when we look at the paleo tsunami record going back, one of our best ways of kind of getting a chronology, and then also looking, Chris Goldfinger's work on these large submarine landslides offshore, thought that they might be triggered by these big earthquakes. We find an average recurrence on the entire subduction zone, roughly 500 years. Sometimes as long as 800, sometimes as close as 180 years. So not clockwork. So the overwhelming majority of earthquakes, essentially all of them that we've recorded in instrumental time, are occurring on the Mendocino Fault, like the ones I talked about today, or are occurring on faults within the Gorda Plate. The Gorda Plate is being crushed because of the movement of the Juan de Fuca Plate to the north and the movement of the Pacific Plate to the south. So our big recent earthquakes, in 2021, there was a Mendocino Fault earthquake. 11 seconds later, a 6.0 in the Gorda Plate. December 2022, Gorda Plate. 1980, Gorda Plate. 1991, Gorda Plate. The Gorda Plate is the most likely source of the next damaging earthquake in Eureka, Arcata, the populated areas of the Humboldt Bay area. We had a 7.4, seems to be the largest historic event in the middle of the Gorda Plate in 1923, 2005, a 7.2. So these are really common. And in the next 10 to 15 years, I will be very surprised if we don't have another upper magnitude 6, lower magnitude 7 earthquake in the Gorda Plate.
Are those faults in the Gorda Plate, are they north-south orientation?
No, the faults are northeast-southwest, and they follow the fabric, the geologic fabric. If you look at the bathymetry, the Gorda Plate has been squished. As I say, it's sort of being squeezed into a vise, and its response has been to deform and to produce all primarily northeast southwest oriented strike slip faults. And these faults are retained within, remember that whole plate is still subducting. So as it goes under us, those planes of weakness persist. And those are the faults that produce the 2021 and 2022 earthquakes. 2022 was almost completely underneath us. The rupture began near Faults Cape and then ruptured, about 12 miles to the east, northeast towards Hydesville, almost entirely underneath the North American plate. And we think that fault recurs, earthquakes recur on that fault. 1975, there was a 5.7 on that same fault, had very similar impacts to what happened in 2022. So once you have a plane of weakness that was produced by this sort of crushing offshore, those planes of weakness continue as the plate is subducted beneath us and continue to produce things that tickle us.
Thank you.
Good question. Thank you. Other questions?
Hi, this is Kristen. Sorry, I'm not on camera because I'm at work and trying to be sneaky. I have a question about this tsunami zone. I know what it is, and I'm in Old Town, and like across the street from me is in the zone, but I am not.
Right.
And I think a lot of people picture the 2000.
Putting everything into when I organize it, I put it into contract credit reg.
Wait a minute. We've got two
but then
people talking
it's
at
in
once.
the archive.
Well, everything is.
Can Ollie turn off so I can listen to Kristen?
Ollie did. Ollie just did.
Okay, Kristen, please continue.
Thank you. Sorry. Anyway, my question is, I think a lot of people picture that 2004 tsunami in Indonesia when they think of a tsunami. And so it's kind of hard to judge, like, what is the logic in like Old Town? A lot of Old Town is right on the bay and not in the zone, whereas like Freshwater Corners is. Like, can you explain, is it because of low-lying areas, or how is that determined, I guess?
Okay, let me explain. There are two things here. The first thing I'm going to talk about is the hazard zone and why it looks the way it is. And the second I want to talk about is what is a reasonable way to respond. So the tsunami hazard is a function of obviously the size of an earthquake source, but also the offshore shape and the onshore topography. Now, one of the things that makes our situation in Humboldt so very different than Oregon and Washington is that our that subduction zone, that big fault that's going to generate the magnitude 9 earthquake and cause the tsunami, well, at least a third of it is on land beneath us. So where we're all sitting right now in Old Town, maybe 7 miles beneath you, where I'm in McKinleyville, 8 miles beneath you, at Petrolia, maybe 6 miles beneath you. We're sitting on top of that rupture. And that rupture might start somewhere near Willow Creek and then rupture up and finally end up maybe 40 miles offshore, about where the continental shelf is. So the same rupture when you're in Oregon and Washington is completely offshore. So the subduction zone gets further and further offshore as you go north. Where we are, that slip is actually not going to disturb nearly as much of a water column as once you get to Oregon and Washington, simply because that rupture is displacing land and not the sea. So that's one of the reasons why the California tsunami threat is not as significant as what we think it is for a Cascadia earthquake in Oregon and Washington. Now, that doesn't mean it's not significant. We're not talking about 100-foot tsunami here. We're talking about something that might be 30 to 40, which is quite capable of doing an awful lot of damage. In addition to the source, and the subduction zone is not, we're not storing quite as much strain down here because the convergence rate is less. We've also got all these secondary faults in the Gorda Plate that might be taking up some of the motion. But we also have a pretty steep coast, and we have Humboldt Bay, and we have the Spits. And the North Spit in particular does a really good job of protecting the Arcata arm of the bay. Now, we certainly expect a tsunami to make it completely over the South Spit and over the lower part of the North Spit, so south of Samoa. In fact, I contend that the reason that the topography of the peninsula is so different south of Samoa is because we're looking at areas that have been planed off by a big tsunami only 300 plus years ago. There's still dunes that are high enough, even in Fairhaven and Samoa, that probably won't get flooded. But that is a tremendous barrier. The bay itself is very shallow. So all of those things are put together in terms of figuring out the likely tsunami hazard. And every location is different. So the tsunami threat in Del Norte County is much more significant, partly because more of that fault is offshore. And again, the configuration of Crescent Harbor. So that's what goes into determining the maps. If I worked in Old Town and was concerned, I would actually be far more concerned about another threat in a great earthquake than tsunami. I would be concerned about fire. And so if I were only a block or so away, I'm going to be looking for the parking lot, the area where there are no buildings nearby within walking distance. Those are going to be my evacuation places, because it's fine if you're, a block or two on the safe side of the evacuation map, and you are more comfortable going a few blocks further in as long as you're on foot. Absolutely. Arrange with a friend. I'm going to come and stay at your house, and as long as it's something you can get to on foot. But Old Town, fire is a huge problem, and everyone who lives or works in the Old Town area should really be identifying those open spaces outside of the tsunami zone that you can walk to. I hope that answers your question.
Lori, thank you so much. You have a question. How will the government cuts impact NOAA and other government agencies involved in earthquakes and tsunamis?
Well, we know what's